Okay, welcome to example number one. We're given a problem where we have a 3-volt battery. So our voltage here is 3.0 volts. And we just write V, not delta V. The current, I, is 0.17 milliamps that is flowing through a circuit, which is powering basically a pocket calculator. This current of 0.17 milliamps should be converted to amps. So that we get our correct answer in the correct units. And we also are told that it operates for 1 hour. So our change in t, our time, is 1 hour. And in 1 hour, that is 3,600 seconds. Remember, there's 60 seconds in 1 minute and 60 minutes in 1 hour. Okay, so for part A, we're looking for how much charge would flow through that circuit in that time of 1 hour. So if you recall earlier, the relationship between current and charge and time is given as the following. I equals delta Q all over delta T, and we're trying to solve for delta Q, which is the amount of net charge that flows through the calculator in 1 hour. So delta Q would be equal to I times delta T. The current was 0.17 times 10 to the power negative 3 amps. And our change in time is 3,600 seconds. And that will give you a net charge of 0.612 coulombs, or 0.612 coulombs. Remember that an ampere is a coulomb per second, so those seconds will cancel out here. Okay, going on to part B, we're looking for how many electrons enter and leave the calculator. And if you recall, the Q is equal to the number of electrons times E, which is the charge of an electron, and E is equal to 1.6 times 10 to the power negative 19 coulombs. So if we're looking for the number of electrons, we would take that net charge and we would divide by the charge of an electron. So that would be 0.612 coulombs divided by the charge of an electron, which is 1.6 to the power negative 19 coulombs. And that will give you 3.825 times 10 to the power of 18 electrons. Okay, so now let's go on to the last part, which is how much energy does the battery deliver in the circuit. So C, we want to look at energy. Now we're given the voltage, and remember voltage is joules per coulomb. And we're also found out earlier the amount of charge that flowed, which is in coulombs. So if you recall, the total energy, which is really it's going to be potential energy, so electric potential energy, is equal to Q times the voltage, delta V or V. So that will give you, that charge is 0.612 coulombs, and the voltage is 3.0 volts, or joules per coulomb. And your final answer will be 1.836 joules, which you could round off to 1.8 joules. And that's it for example number one.